Yeah, hello, and thank you for all these presentations. We had two presentations where we were able to use power data that for implications for both human health and socio and economic. So I think that that's really exciting to see some serendipitous uses
Yeah.
in addition to our typical industries that we support. So we did have one question in the chat. Actually, it was in the chat regarding for Aletsky, and hopefully I pronounced your name right. And the question had to do with the applicability of your results of yield predictions at various spatial scales. So I don't know if you have any thing that you want to say on that, but if you have any comments on that question.
The regenerated series are not exactly looking like normal data that is obtained from the weather stations. I consider the FFT matching represents the content and dwell time of the parameters in both the cases to be same. Medically, the dwell time exposure is the one that is going to affect the human system. So when FFT matches, I consider that as an acceptable representation of the data. So the accuracy is not very much. I mean, like it is not equivalent to generating a weather station like data, but the generated data has the FFT content of at least first 20 frequencies being same in both cases. I consider that to be okay for my purpose. Sorry.
Yeah. All right, thank you for those extra comments. And we were just had a question that's specifically directed to Oletsky
Yes.
regarding the spatial scales of his crop yield. So I didn't know if he was going to be able to comment on that.
Yeah, we have as I mentioned in the presentations that we provide the yield forecast on different scales, on a regional scale. Well, I mean that it depends on administrative division of the country, and then for example, for Ukraine, where you see this example that we have two different forecasts. I mean that on a regional level and on the district level, well, for example, we have in Ukraine, it's about 25 regions and 500 districts. So it's a different, and also we are trying to use, and we have some first results to use this approach on a field level yield forecast. Okay, and well, I would say that the accuracy, for example, for the regional level, we reach close to the 90%. Well, in the 1 month in advance, and for the field level, it's less, of course, but we got a reasonable figures for yield prediction on the field level.
Okay, well, thank you. Just wanted to ask all the presenters. I noticed that two of you were looking at computing evapotranspiration related indices. And of course, we're always looking to help or provide extra additional parameters. So I was just curious if it would be helpful to provide those more directly. Also to Daniel, we are now, you can order through our API, the GPM data, if it makes it easier for you, but we just feature the daily average data. So I was just curious if that would help you streamline your process. Of course, I'm not trying to tell you not to get it directly from the GPM mission, particularly if you're not using the data set we are, but I was just curious if that might help streamline your calculations too. Thanks.
Oh, that's good. Thanks for mentioning the GPM. We're actually caching all the data on our side. So we bring the original TIFF files, and we're bringing the GPM delayed and the final product and mixing them because we want to have something more up to date. So, but we'll take a look at the data that's provided through the API for GPM because that might ease our situation here. Thanks. And for the evapotranspiration, that's a good idea too. I think we are calculating it based on some. We're not using we're using a simpler model instead of the full FAO 56. We're using a modified Graves-Samani model. But if power provides that evapotranspiration, that's an interesting variable too. Thanks.
Sure. Thank you. And the question also goes out to Eleanor in regards to the evapotranspiration index she's computing as well. Are you making some assumptions there that could be improved with some additional parameters or information?
I don't think that there are assumptions necessarily. The SPEI is pretty standard in that it only takes in temperature, precipitation, and latitude. So it's not all that difficult to calculate manually. I was using the NASA Power packages and some other packages that come loaded into R to calculate the SPEI, so it wasn't so labor intensive that I would expect you guys to do the calculations for me, if that makes sense. But also in that it's so simple, if it was something that you wanted to add, it's a very helpful, index and very simple, just being -3 to +3. It doesn't take too much, deep understanding or really, really intensive interpretation. Yeah.
Yeah, thank you for those comments. Mera2 provides that parameter estimate from their output, but you can compute it since the solar radiance is part of that calculation. We have seen, for instance, global evapotranspiration data sets using the GWEX SRB data and other data products like the series data products. So having the observed solar radiance might help make those evapotranspiration calculations a little more accurate. And so I was just curious about the utility of doing that sort of thing. So something that we mentioned adding more hydrological parameters, and I think these two talks here exemplify why we want to do that. So I really appreciate everyone's talks, and particularly those of you who are up at a very later early time. So thank you for getting on. And we are about to transition to our last panel of the day. So so looking forward to the talks, and I'll hand it over to Claire. Go ahead.
Thank you again to our second round of Lightning Talk presenters, another great round of user stories. To kick off our third and final round of Lightning Talk presentations, I'd like to introduce Eric with Saildrone.